All right, we're going to talk about eccentricity today. The idea is that eccentricity will help us determine what a polar graph is going to be, predict what a polar graph is going to be. And if we know something about eccentricity, we can predict how stretched an ellipse or hyperbola is going to be. Okay, those are the purposes of learning about eccentricity. All right, when we talked about the different conics, how many different conics did we talk about, guys? Think harder. 4. There were 4 kinds of conics. There were circles, parabolas, ellipse, and hyperbola. Okay, which of those have 2 foci? Okay. An ellipse has 2 foci and a hyperbola has 2 foci. Okay. A parabola only has 1 foci, right? Do you remember what happened with a circle? When we took the string and we put 2 pieces of tape and we taped it up and it made an ellipse, right? Do you remember how we got it to make a circle? Yes, we took those 2 pieces of tape and we moved them right on top of each other, right? Okay, so the foci moved together and became one spot and it was the center of the circle. I'm going to talk about that in a second here. All right. It says, recall that ellipses and hyperbolas are defined in terms of 2 foci and both have 2 vertices that lie on that line. Okay, I want to draw a little ellipse here and I want to draw, that would, yes, and a hyperbola. Okay. Now, the foci are inside here, yes? And there is some kind of a line that runs through here, and this blue distance is going to be the distance between the foci. And the vertices of an ellipse, we're going to call those at the ends of the major axis the vertices. Okay, and those, the distance between the 2 vertices. Now, does anybody remember what we called those distances? What did we use to find the foci? How did we find the foci of an ellipse? C squared equals, right? Right? So from the center out to the foci, that distance was C. Do you remember that? Okay. So the total distance from one foci to the other would be 2C. Everybody okay? Whether that was at the origin or somewhere else, that distance was C. What was the definition from the center to one of the vertices? Does anybody remember which letter gave us that? It would be A, yes, because it's the larger one on an ellipse. So A was the distance from the center out to one of the vertices. So from one vertice to the other was 2A, which was also the major axis, right? All right. Now I want to talk for a minute about ellipses. What happens when you have an ellipse? This is a hyperbola. When you have a hyperbola, where are the foci? Okay, so if this is a vertex and this is a vertex and we have a center in here somewhere, this distance was A still. Do you remember that? A is always the positive one, which determined which way it opened. Okay, so this distance is A, or the total distance between the vertices is 2A. The distance from this focus to this focus, remember, from the center here, that C is for center. How did you find out where the focus were again? Foci? A squared plus B squared, right? But this distance was C still. So the distance from one foci all the way to the other foci would be 2C. All right. The definition of eccentricity is the distance between the two foci, which is 2C, over the distance between the two vertices, which is 2A. Well, what can we do with that, guys? Yeah, we can cancel out the 2, so we get C over A. This is what you need to memorize, that eccentricity is C over A. That's it. Okay? Now, E, by the way, in the way we're using it, stands for eccentricity. Does anybody remember what E stood for earlier in the year? Yeah, was that inverse of natural logs? It was a number that had to do with all kinds of crazy stuff when we're doing logarithms, right? You should be able to tell which it is based on the question. All right, you have this on your paper. I was trying to get you there without showing you this, but the distance between the foci is 2C. The distance between the vertices is 2A. When you divide, you get C over A. Here they've replaced C with how to find C. Okay, this is the definition of eccentricity. Now, I want you to think about that. Which of those is going to be bigger, 2A or 2C? On an ellipse, always 2A is going to be bigger. So when I reduce C over A, C is one of those blue distances right here, and I divide it by A, what am I going to get? A number more than 1, less than 1. Oh, that's A, not C over A. Less than 1. Everybody see that? The C is going to be shorter for an ellipse, okay? It can't be negative, but it's going to be somewhere between 0 and 1. All right, look over here. When you have the distance between the vertices here for a hyperbola, this is A. The distance between the foci, that was C, so from the center is a C. When you put a C over an A, the blue over the red, you're going to get a number what? Bigger than 1. Okay? So when you have a hyperbola, the eccentricity is going to be greater than 1. All right. And it can be, 1.2, and it can be all the way up to 5 or 6 or whatever. Now, we have two conics we haven't talked about. Do you remember what happened with the circle? When we moved the foci right on top of each other, how far apart are they now? 0. So the eccentricity for a circle is going to be 0, because there's no distance between those foci. They're right on top of each other, okay? The issue with a parabola is that, do we even have 2 foci or 2 vertices? No, okay? Well, look at these down here. What do you think it might be, would be a parabola? Exactly 1, yes, okay? Parabola, by definition, has an eccentricity of exactly 1. All right, do you have this at the bottom of your page? Okay, so we tried to develop this by thinking about C and A, but you need to know that whenever E is between 0 and 1, it's going to be an ellipse, and whenever it's greater than 1, it's going to be a hyperbola. Now, let's talk about what that means in terms of the picture, whether it's a lot less than 1, really close to 0, a lot more than 1. What does that do? If you have an ellipse, okay, The eccentricity measures its distortion from a circle. So when you have something like 0.5 or 0.2 or 0.1, you have a very narrow ellipse. Okay? When you get closer to 1, I just said that totally backwards. Okay. Circle is 0. If you get to 1, it breaks apart and becomes a parabola. So in between there is where it gets narrower. So when it's really close to 1, that's when it's narrow. Okay? When it's really close to 0, it's very circular. All right, they're supposed to be color-coded on your paper, and it's hard to tell what's what. All right, sorry. I will highlight down here, it says, in a circle, the two foci coincide, so the eccentricity is 0. All right, as the foci move further apart, the eccentricity increases and the ellipse becomes more distorted from a circle. All right. Here, when you get past 1, it's like that ellipse breaks apart and swings around and you get 2 shapes like this, which are the hyperbolas. It says, as the foci move further from the vertices, the branches become straighter and approach vertical lines. They will not actually be a vertical line, but it will look vertical if you graph it on your calculator after a certain point. But here is close to 1, okay? Here the eccentricity is greater than 1 by a lot. When it gets to be something like, 3.5, 4.5, 5, they're very straight. Okay, the eccentricity of any parabola is defined as 1, and we're just going to go with it. I'm not going to spend time going through their explanation of that. You have this on your paper, yes? A little box that summarizes all that. The only one it doesn't have is what? E equals 0 is a circle. All right? Everybody got down what they want? All right. You have this on the back of 18? Yes? Okay. But we need to do these 2 questions. We're going to calculate the eccentricity, and what's the definition we're looking for? C over A. Do we know what A is? Is this an ellipse or a hyperbola? Has a minus, that's a hyperbola. You're having the problem I had today. You just can't say the right words, okay? This one's going to be a hyperbola, and we need to check at the end that the eccentricity comes out appropriately then. Right now, when you have a hyperbola, which one's A? It's not the bigger one, it's the positive one, okay? So A squared is 4. A is 2. So actually the distance from one vertice to the other, if we were to graph this, if it's at the center is at 0, 0, so it would go up 2 and down 2, so the total distance between those vertices would be 4. All right, how do we find C? When this is a minus, we do plus, right? So C squared equals A squared plus B squared. 4 is already A squared, and 21 is already B squared. So we get 25, and that makes C 5. So the distance from the center to the focus is 5. Okay? This is A, and this is C. All right, so what's the eccentricity? E is just 5 for C over A, which was 2. That's like 2.5, right? So what does that tell us? Does that make it a hyperbola? It's greater than 1, right? So it checks. All right, B, part B did not go well for a couple of you on the quiz. When you had to complete the square, you didn't have to find eccentricity, but the completing the square didn't go well. Some of you are still struggling with that, the negative. Let's go through this quickly. I'm going to rearrange. And then I need to factor out a 4 out of these first two. What does that leave me? Plus blank. What do I need to take out of these second two? A positive 9. This one doesn't have a negative to worry about. All right, I need some calculator help here. I take half of this and get x minus 4. When I want to make that equivalent, this would be a 16, not a 64. Four times 16, though, is what we have to add to the other side, and that's where some of you messed up on the quiz. Back here, we get a y minus 5 squared is a 25, but 9 25. Somebody helping me? And then over here, negative 253 plus 64 plus 225. I'm going to take a wild guess that it's 36. Is that right?
36.
Just because I knew it was probably something divisible by 4 and 9. Ah, 4 goes into 36. 9 times. All right, let's worry about the eccentricity, and then I want to address a couple things from the quiz while we're on this slide. Eccentricity is just C over A. What is A? When you have an ellipse, A is always which one? The bigger one, not the first one necessarily. So A squared is 9 here, which makes A 3. All right, how do we find C? C squared equals A squared minus B squared, so 9 minus 4, square root of 5. Now, is that less than 1? Can anybody type square root of 5, then divided by 3? Yes? Okay. It's less than 1, so that does make it, in fact, an ellipse, which we figured out, right? Our equation was that of an ellipse. All right, just really quickly, I had some of the people on math team, not necessarily in this class, but they wrote this 2/3 x for the asymptotes. Can anybody evaluate the error there?
You have to put in the values of 4 and 5.
Okay. This goes through the origin, right? These two lines go through the origin. Is this ellipse centered at the origin anymore? No. So the equation you should have been using was y minus k equals plus or minus, for this ellipse, I don't know, it was b over a, right? X minus h, okay? Just wanted to throw that out there because that was a struggle for some people on the quiz. All right, Guys, I need everybody focused here. We're going on to the next page, talking about the kinds. This is really why we're doing this, okay? What this has to do with is polar graphing. The predicting what a polar graph is going to look like is based on the eccentricity. All right, so polar equations of conic sections. These are still your conics. We still have circles, ellipses, hyperbolas, and parabolas, okay? It says the equation, this is what you need to know for these right here. You need there to be a 1 right here. This must be a 1. And we're going to talk about how to change it so that it is a 1. If it's not a 1, we have to find a way to make it a 1 right there. Once you have that as a 1, whatever's multiplied in front of the cosine or sine right here will be the eccentricity. Okay? This top number has to do with d being the distance from the focus at the pole to the directrix. I don't care. Okay? We're not going to do anything with that. We just need to figure out what E is, because the eccentricity will help us predict what it's going to be. Again, less than 1 an ellipse, exactly 1 a parabola, greater than 1 a hyperbola. Now, these two equations it shows have cosine in them. What do you notice about the symmetry of these three graphs? If I were to draw lines of symmetry, all of these graphs have which? Yes, they would have horizontal lines of symmetry. Does everybody see that? Those go with cosine. Does that make any sense to you? Cosine, x-axis symmetry, right? Or some kind of horizontal symmetry. By the way, some of these will open this way, okay? I can write symmetry up here for you, right there. Okay. These, again, you have to have the 1 there. And the E will be whatever ends up after we've gotten the 1 there, what's in front of the sign. Positive and negative. The positive and negative has to do with whether it opens up, down, or sideways, or whether it runs long and skinny the other direction, okay? But again, the ones with sign will all tell us what? That the symmetry is vertical, okay? Everybody okay with that? All right. What I want you to do, this slide you do not have. I want to just play around with the calculator for a minute. Put your calculator in polar mode. I'm going to go with degrees because we all seem to think better in degrees. These are actually usually done in radians, but it doesn't matter for what we're going to do. Okay? So mode, degrees and polar. Then we're going to go to y equals. And you don't have this slide, but this is what I want you to do. I want you to put in a 0.7 for the eccentricity and see what you get. So I'm going to type 3 times 0.7. You can put it in parentheses if you want, but it doesn't matter. Divided by, we do need a parenthesis for the bottom so that it does the adding. 1 plus 0.7 cosine of theta. Close those parentheses. Now, your window is, if you're in degrees, 0 to 360 by 1 or 5 or 15, but if you want to be nice and smooth at 5 or 1, 1 takes a while on my calculator. And then I did a zoom square, okay? I did a zoom square so that it came out nice. What shape did we get? An ellipse. Did that make sense for a 0.7 eccentricity? Okay? It is an egg. I'll go with that. Okay? Now, what are we supposed to change it to for the... Did you not get it? Your window needs to be 0 to 360, and then I just did a zoom square so that it showed up proportional, otherwise it'll stretch it. Anybody else not getting it? All right, what are we supposed to change the 0.7 to, guys? For part B, I want you to change the 0.7 to a 1. And I'm not actually going to delete it. I'm going to leave it in there because I'm going to change it to a 2 or something in a minute. Now when I graph, I get what? Do you notice what it does? Yeah, it did one side and then the other. If you watch, it has to do with the fact that it's rotating from 0 to 360. Watch this, guys. I'll turn the little bouncy ball on. It's rotating around. Okay? Does that kind of make sense? Okay? But for exactly 1, we got a parabola. Is someone's not working? Yep.
So, where's the other one? Because if it's a hyperbola. Oh, I know.
No, this one is just a parabola because E is 1. Now we're going to do the hyperbola. So we're going to put in what? What does part C say under there? Put in a 2? Okay. This time I have my bouncy ball on, so you'll see it's rotating around and it comes back and goes a second time because of the fact that those functions repeat. But did you get this? Okay. Again, these all had x-axis kind of symmetry, horizontal symmetry, because they were cosine graphs. All right. When they look like this, I took some snapshots for you. Everybody good? All right, let's try this. I don't want you to do this on your calculator. Some of you already did it on your calculator. Okay? And I'm good with that. But for the homework, you have to know how to do this to make that a 1. Is everybody ready? Okay. No, multiplying by 4 isn't going to do it. We need this to become a 1 right here. Okay? We're just going to divide everything on the top and everything on the bottom by 4. So this will be 20 over 4. This will be 4 over 4 minus 10 over 4. Okay. The top will reduce to what? 5. And the bottom will become 1 minus 5 halves, or 2.5. 2.5 is fine. Okay. What did we just figure out? The eccentricity is, it said find its eccentricity. We found out the eccentricity is 5 halves, or 2.5. Okay? Thank you. What can you tell me about this shape? If it's 5 halves, it's going to be what shape? It's going to be a hyperbola because it's greater than 1. Okay? Now, what's the symmetry going to be? It is a sine, so there's going to be vertical symmetry. Okay? Now, you can type in either one of these. You can type in the original one or the reduced one. Okay? If you want to see the graph, now, did it do something crazy when you put it in? It does something crazy because it's connecting all the dots, and there's so many dots that it actually drew in the asymptotes. If you look really closely, can you see the hyperbola there? But it actually connected the asymptotes. Look, I'm going to put mine instead of connected mode down here. If I go to mode and I go over to dot instead of connected. Why does it say it was already in that mode? Okay. Did you guys do it in dot mode? It worked fine last period. When I put it in dot mode, it looked like this. It didn't draw in the asymptotes. Did anybody get it to work if you put it in dot mode?
I do it thick because like it's just
Guys. I want to turn my little bouncy ball on. All right, let's finish this up. I want you to try to do these 6 without graphing them on your calculator. You do not have this, it's your actual book work. This is your actual book work, okay? So let's look at these 6 equations. Number 1, what is the eccentricity? This is already a 1 here in front. So the eccentricity right in there is 1. Okay, what does an eccentricity of 1 mean? It's a parabola. Now, this particular parabola is a cosine, so it should have what? X-axis symmetry, which means should be opening left or right. I'm guessing D. Okay, it's actually the opposite of what I was thinking because of the minus. I think I don't have enough practice with these. But it is parabola. Okay, number 2. What's wrong with number 2? I can't have a 1 there. So if I divide everything by 2, I get R equals 3. 1 plus what? 1/2. What does that make it? This should be an ellipse. And it should open, or it should have which kind of symmetry? Horizontal again, so it should be, which one? F? Okay, do you get it? You guys can finish these?
yeah. We have to write them down. We have to write them down.
You have to do this, it is the book assignment is 1 through 18, all on page 752.
That's it.
Yeah. Okay. The next homework check is Monday, and there will also be a homework check Thursday next week on the chapter 12 stuff. Yeah. What's wrong?
We pushed the Thursday homework check to Friday.
If you all agree to come in on Good Friday, right? It wouldn't be a very good day if we had to come, so. All right. I'm going to stop recording, and then I want to go over